Welcome you all to this session on modulation. So let's start with the introduction to modulation. What is this modulation that we're talking about? So when you want to send any information or data in particular broadcasting service, you have to exchange it between two stations referred to as source and destination. And at any point of time, there should not be any loss of information. So when it is being transferred here, you must have seen different people talking to each other. So there is an exchange of information. It can be through multimedia, through discussion groups, through loudspeakers. Anyway, these are all the different ways in which the communication is transferred. Okay. Then this is general communication, and this is the electronic communication. Nowadays, people are talking not the physical communication because of the pandemic also. So people are talking about the communication through emails, social media apps, WhatsApp, Facebook, YouTube, and so on, Twitter. These are all different electronic communications. So when we've seen so many types of communications that are available, what actually communication means? So you can whisper, you can shake hand, you can give a letter, you can talk over the voice box. So basically this is referring to passing on the act of communication. So the word communication refers to the act of communication. This can take place between two humans in the form of speech, facial expressions, gestures. So we have already studied and we know that we have different ways of electronic and non-electronic means of communication. So non-electronic is through messengers. Pigeons, earlier days people used to send information through pigeons, and they just play the drums to make some announcements. Earlier in age-old days in villages, when the movie is released, they used to carry those boxes, huge boxes, which is actually a reel. And then that reel, when it is being telecast, when it's being released, when a movie is released, they used to play drums and say that so-and-so movie is released. Watch in these theaters. And after so many days are over, that reel will be passed on to another village or another place. These are our non-electronic means. Now we don't have to do all this. We have all electronic, all magnetic tapes, digital technologies, CDs, whatnot, over the internet. You have now AHA channels, over the top OTT, that is over the top broadcasting services, satellite communication, fiber optical communication. All this is electronic, are also known as digital way of transmitting. Now, latest is of course email, voice assistants. You have this, what are they? Alexas, okay, Echo Dots. These are all voice assistants. TV is another multimedia application. Mobile phones, iPhones, whatnot, tab phones. Okay, whatever be the type of communication that we are talking about involves a couple of steps. Let us try to understand the steps that are involved in transmission of information. The origin of information. First, what is it that you want to send? The person who is sending the information should have a clear idea of what he is sending. So, what he or she wants to communicate. Then, process the message signal such that it will have the capability to travel for a longer distance. Whenever you want to send any communication, if it is to a person next to you or a person in the next room, you can just raise your voice and they will be able to hear. Imagine you are sending some information, some announcement in the college. What do you normally use? You use a microphone, which amplifies your voice, your signal, so that it reaches to a larger audience. Same thing, if it has to reach to a longer distance, you use a telephone. If it has to reach to overseas, you use electronic mail or voice mails or social media. So this is a means. Then you have to process it because it has to be amplified or it has to be converted analog, digital, or whatever it is. and then sent to the desired destination. Now, at the destination, this is reception of the processed image that takes place at the desired destination. Processing the received message signal in such a way that to get back the original signal. Finally, deliver the information from the message signal to the intended person. So these are the steps that are involved in transmission. Now, what are the elements of a communication system? What are all required? We will go in detail about these things. In this class, let's just understand the block diagram of this communication system. This is a signal or the information. This information has to be converted to an electronic signal. So, if it is not electronic, like speech, music, or whatever it is, you have an element called transducer, which will convert this analog into a digital signal. It senses, it's like a sensor. Senses, picks up the signal, converts it into an electronic signal. Then you have a processor, which processes the signal which is required to be transmitted. It will be transmitted. This will be transmitted through the space in the form of electromagnetic waves. Finally, this wave will reach the receiver. Then from the receiver, the electronic signal is again converted back to the audio signal by means of another transducer. So these are the different ways in which the information is processed, transmitted and received. So what are these elements what we've written there? First is information source, sent to a transmitter, then to a receiver. In between you have a channel, and from here it is sent to the destination. Now, what is this transmitter doing? This is encoding. Supposing you don't want to send the information directly in intelligence and other military applications, they encode it. They send it by secret means of codes, and then it will be sent through a channel. Channel is a medium through which the signal is processed and transmitted. And receiver is where you have to decode the signal. You can't send the coded information. The person at the other end should be able to listen to or receive your message. So it has to be decoded. Then in between these two, there will be a possibility of some noise also coming. So original signal may be disturbed. That has to be recovered properly and sent back. Okay, we are talking about signal. What is basically a signal? Okay, when you talk, when you are talking, when you are singing, when you are speaking, all these are signals. But they carry only to a short distance. So it's like going to a nearby place, going to far off places. If it is a nearby place, you can walk down and then come back. If you are staying very close to college, you can come walking to the college. Say suppose you are a little away, staying away from the college. You need to be transported by means of a vehicle. Right? You sit in a vehicle, a bus or a car or your own vehicle, travel and reach the college. Once you reach the college, you park your vehicle somewhere, attend all the classes and go back. So, to allow it to travel over longer distance, what we require is to increase its strength. Right? Strength means you don't have the strength to walk long distance. You are acquiring the strength by sitting in a car, bus or so and so. But after you are dropped, you should not have any difficulty in reaching the destination. It should be the same. So the signal which is being carried by a signal called carrier signal should not disturb its parameters. It should allow it to reach to the destination in the same way. That means there should not be any loss of information. Okay. Now, you have understood that signal in its own original status or original form cannot move over longer distances. That means it needs to be given extra energy, or it has to be carried as was the case, as was discussed in an example. So when you want that kind of a thing, what is it that you should do? You must attach this signal which is carrying the information with some other signal, take help of another signal which is having higher frequency. So this higher frequency signal should not change the characteristics of the message carrying signal. They both should combine. So this process of combining changing the carrier can change according to changes, right? What does it mean? Say suppose you are taking a car from your home to college, okay, and if there is a roadblock near your house, what should you do? You must either come onto the main road and take a cab or a car, or the car should take another route so that it will be able to reach your house, pick you up and drop you in the college. So what is it trying to do? Changing the parameters of the carrier signal in accordance with the instantaneous values of the modulating signal. See, modulating signal can be like a speech or it can be a music. Suppose you are singing. Those who are singing, they sing sometimes, there'll be some modulation in their voice. They go at high pitch for some ragas they go lower, they lower their pitch, or for some it is just normal pitch. Pitch is, the pace with which you are singing. So depending on these changes, the carrier signal also will be changing. So therefore, this signal in its original form is called a baseband signal, and it is incompatible for direct transmission. For such a signal to travel longer distances, its strength has to be increased. How do you increase the strength? By modulating it with a frequency which is a higher frequency, and we call this as a carrier signal. Doesn't affect the parameters of the modulating signal. Okay, usually the height of the antenna is what you see on your terrace, which carries this information. So generally 1/4 of wavelength, lambda is wavelength, is efficient transmission. For efficient transmission, this much is needed. So when you calculate frequency is 30 Hertz, your height should be 2500. So frequency, what happens? Frequency, what is the relation? V is equal to n lambda. So velocity is this divided by lambda will give you the frequency. So if the frequency is low, the height of the antenna is high. If frequency is increased, the height is reduced. So frequency increases, height of the antenna decreases. As frequency increases, the height will, you cannot provide 2005 kilometers antenna. TV antennas you must be seeing, it won't be that much. So if you increase the frequency to megahertz, the height will be reduced to meters. So therefore, you have to always modulate the signal, mix it with a carrier wave. Now what are the advantages? The antenna used for transmission had to be large if it is not used, as you have seen. The range of communication is limited. See, the range means the distance through which the signal is communicated. That distance will be less if you do not modulate. If you modulate, the range can be increased. Also, what are you doing in modulating? You are increasing its frequency. When the frequency is increased, you can see frequency is increased means all the peaks will come closer. Okay, so then when the signals are low, when the frequencies are low, they are very close to the surface of the earth, there will be some disturbances occurring. So as you go higher up to the higher frequencies, what happens is their signal mixing will not take place, there won't be any interference. Okay, then multiplexing of signals also occur, so that also will take place. Bandwidth, what is a bandwidth? The channel width over which the signals are transmitted, that also will be improved. Reception also will be better. Message or a modulating signal. So the signal which contains message to be transmitted is called as a message signal. This is also called as a baseband signal, which has to undergo the process of modulation to get transmitted, hence it is also called as a modulating signal. So try to understand the difference between modulating signal and baseband signal. Next you have what is known as a carrier signal. What is a carrier signal? This signal which has a certain phase, frequency and amplitude but contains no information. Okay. So original signal is signal carrying information. This is only a carrier signal. This has no information. It's an empty signal. Okay. It is used to carry the signal to the receiver after modulation. So when you mix these two, resultant signal is the process of modulation. And this is called the modulated signal. This is a combination of modulating signal and the carrier signal. So what are the different types of modulation that you will be studying? You represent a carrier wave by this formula V is equal to A sin omega t plus phi r theta. Then you have A is amplitude, omega is frequency, phi is phase. So it is the carrier wave's attributes or characteristics that you are changing. If you change amplitude, it becomes amplitude modulation. If you change frequency, it is frequency modulation. If you change phase, it becomes phase modulation. Frequency and phase together, frequency and phase together is called angle modulation. So, in a broader sense, the type of modulation that we are talking about is divided into continuous wave modulation and pulse modulation. Okay? This continuous wave modulation can be further divided into amplitude and angle. This angle is again frequency and phase. Okay? Then pulse modulation. These pulses can be either in the form of a digital pulse or analog pulse. If it is digital, it is pulse modulation or also known as delta modulation. If it is analog, it is pulse amplitude modulation PAM or pulse width modulation or pulse position modulation. We will be discussing these topics in detail in my few lectures which follow. So first we will discuss about amplitude modulation, then we talk about frequency modulation, which is part of the angle modulation. Then we talk about digital and analog modulation, and in digital modulation we have pulse coded modulation and delta modulation. In the next semester we will be talking about I think this semester also we have a small introduction to PAM, PWM and PPM. So therefore we have to concentrate now on continuous wave modulation. In the continuous wave modulation, a high frequency sine wave is used as a carrier wave. This is further divided into amplitude and angle modulation. So if the amplitude of the higher frequency carrier wave is varied in accordance with the instantaneous amplitude of the modulating signal, then such a technique is called as amplitude modulation. What it means is, if amplitude of the modulating signal is increasing, amplitude of carrier wave also will increase accordingly. It will also increase accordingly. Say suppose a bus is carrying 10 people at different places, at different destinations. What it does is, suppose all of you are on the main road, the bus will pick you up from the main road. Supposing one person is staying very much interior and they cannot come on to the main road, what will the bus do? It will take the road where the person's house is located, go into the lane, pick them up and then travel. So you are changing, the carrier is your bus. It is changing according to the destination, the person who is boarding the bus. If they are staying interior, they will go into the colony, pick them up and do. So like this, in the case of carrier wave, if amplitude is changed according to the changes in the amplitude of the modulating signal. So it's like, adjusting the mic. If you are a low pitch, it will reduce. If you are talking at a high pitch, the amplification will automatically be decreased. So it's adjustment, and that is known as modulation. If the angle of the carrier is varied in accordance with the instantaneous values of the modulating signal, then it is called angle modulation. So the angle modulation is again divided into phase and frequency. So angle is changed means if frequency is varied in accordance with the instantaneous values of the modulating signal, then such a technique is called frequency modulation. If the phase of the frequency, that is angle, is varied, then it is known as phase modulation. So we have seen the definition of amplitude modulation, frequency modulation and phase modulation. Then you have pulse modulation. In the pulse case of a pulse modulation, a periodic sequence of rectangular pulses is used. Instead of a sinusoidal wave, we use a rectangular pulse. which is further divided into analog and digital modulation. So in an analog modulation technique, if amplitude, duration or position of a pulse is varied in accordance with the instantaneous values of modulating or a base signal, then such a technique is called, if amplitude is varied, it is called pulse amplitude modulation. If amplitude is varied, it is called, if duration is varied or width is varied, it is pulse duration or pulse width modulation, or if position is varied, it is pulse position modulation. The only difference between this amplitude and this pulse amplitude modulation and original amplitude modulation is, there in case of just amplitude modulation, the carrier wave was a sinusoidal wave. In the case of pulse amplitude modulation, the carrier wave is what? It is a train of pulses. Okay, that is the difference. Then you have digital modulation. This is the technique which is used in pulse coded modulation, where the analog signal is converted into digital forms of ones and zeros. As the resultant is a coded pulse train, this is called as PCM. It's coded, therefore it is pulse coded, which is further developed as delta modulation, which will be discussed in subsequent chapters. So PCM is a technique where analog signals are converted basically into digital form. Okay. So this maybe you can just, I'll leave this thing. If you can enter a small puzzle, it will be nice. Just try if you can.